Our first award category is the Best DevSecOps Project of the Year Startup, and the winner is Deep Factor. To talk more on that, let's all welcome Mr. Kiran Kamiti, founder and CEO of Deep Factor.
Thank you, Niladri and team, for the opportunity, and thank you DevOps India Summit for recognizing Deep Factor and giving us this award. I'm really excited. Deep Factor is creating a state-of-the-art AppSec platform that utilizes the concept of continuous AppSec observability. And it's really the right way to set up your DevOps pipeline and add security to it, especially if you're modernizing your application or building your applications with containers, Kubernetes, so on and so forth. It's exciting to be recognized for the technical innovations that we're creating. A little bit of background of Deep Factor. We're a company that is based in Silicon Valley, and we have offices in Bangalore as well. We have a significant engineering presence in Bangalore as well. The company is created by a bunch of veterans in the areas of containerization, Kubernetes, AppSec, and other areas of security and DevOps. Lots of bright minds have come together over the last 2.5 years to build the core of an observability platform that shines, with respect to application security. In short, what the platform really does is it observes billions of events that are inside your application process at runtime without you having to change any code of your application. Things like your application's process behavior, file behavior, memory behavior, etc. All of those things are captured by Deep Factor. And anomalies are detected, and anomalies are presented in such a way that you can identify your software supply chain. You can identify your security risks in the application. You can also identify compliance risks in your application. This enables AppSec teams to set guardrails so that when an application deviates from those guardrails, the engineering teams are notified as part of their development process, sometimes as part of their CI pipeline, depending on how you configure it, so that you're always up to speed on how your application is running, whether it is secure or not, whether it's compliant or not. Is there any unexpected thing that has been added into your software supply chain, so on and so forth, by observing an actual running application. That's the significant area of innovation. It's not just scanning your code or scanning your build images, it's actually observing a running application. All of this can be done in a language agnostic way. If you are especially building modern applications, you simply drop Deep Factor into your Kubernetes as a webhook admission controller. If you are running a traditional application, Deep Factor runs with that too. But it especially shines if you're creating modern applications. You can set up Deep Factor on any cloud. It consumes very little performance overhead, and you can bake it into your CI platform. That, in a nutshell, is what we do. How do we help customers with their DevSecOps maturity cycle? We've talked to over 100 organizations over the last year, and we can group their stages of maturity into 4 buckets. Stage 1 is companies that have zero or minimal security. That means devs write code, QA tests functionality, and the release ships to prod. Believe it or not, there are many organizations today that still fall under stage 1. Stage 2 is organizations that have gated security checks. These are organizations where the engineering team creates the application, but towards the end of the release, they dedicate a 2 or 3 week block of time for the AppSec team to come in and find issues or find the security risks in the applications. Sometimes AppSec teams find less things, sometimes they find more things. The problem is it's very unpredictable, and it can lead to engineering releases being delayed. And this leads to a dynamic in many organizations where the AppSec team is perceived as the villain, the bad guys that delay my releases. And engineering teams generally don't like security teams due to this process, even though the AppSec team is just trying to do their job. To change this, some organizations have evolved into stage 3. They have basic DevSecOps in place. They have code scanners, SAST tools, static application security testing tools, or dependency scanners, software composition analysis tools, etc. These tools purely look at a parked application because the app is not running there. And they try to find security issues here. They try to bake it into the CI pipeline so that at least they get visibility during the course of development so they don't have to wait till the last minute of the release. Leads to more predictable schedules. The intention is right, however, the tools aren't right. So we are not catching all the security risks in the application by doing this. Stage 4 is where every organization wants to be when it comes to their DevSecOps. It's the holy grail of DevSecOps. It is the ability to observe risks in your application, not just by scanning your code, but actually observing a running application, especially with modern applications, because the touch points of these modern applications are really far too many compared to the traditional way of building, three-tier, the good old three-tier kind of application set. With Kubernetes or microservices, your applications are far more granular, and there are too many touch points. And it's important for you to observe the applications at runtime for you to understand truly what the supply chain implications are in the application. What are all the touch points of the application? What the security risks are, and what the compliance risks are. That, in a nutshell, is where we want to take organizations. We want to take them to stage 4, no matter which stage they are in today, stage 1, 2, or 3. So we started our journey with this customer, Cadent, and that's the reason why we got the award. Is with Cadent, these were the challenges that the customer had. They were trying to modernize their applications. They were taking their monolithic applications and trying to granularize them so that they can have a microservices-based deployment on Kubernetes. With this approach, the customer wanted to, the challenge for this customer was that as they were modernizing it, they wanted to make sure that their security was baked in as part of the release process. So they wanted to have a better DevSecOps pipeline than what is available today. The current approach to AppSec that they had was very reactive. They were in stage 2, if you refer to my previous slide, which means their security was gated. Towards the end of the release, the AppSec team would come in and find issues. They also had code scanners and stuff like that, but it wasn't really, they knew that it wasn't caching all the surface area of the coverage that they wanted. They wanted to get to AppSec being more proactive and more integrated into the development pipeline. Challenge with the current tools was that the existing tools like Asast, for example, which they were already using, they were clear that it lacked runtime visibility. So they wanted something that looked at your Kubernetes cluster when your applications were running in test, in pre-production, etc., or even in prod sometimes, and catch all of these supply chain related issues, security related issues, compliance related issues during the course of development. They also wanted to make sure that AppSec team can set the governance, the ability to define rules, and be alerted if an application deviates from those policies. For example, if a developer brought in some package and that package was reaching out to some location, geography, to fetch another package or for command control reasons, they wanted to be able to catch such aberrations, even if it didn't map to a list of known CVE database. So they wanted to make sure that AppSec team can set the governance, and if any time the application or the third parties that your developers are bringing in, which is 75% of applications these days, deviate from these behaviors, the engineering teams get notified as part of their dev or CI pipeline itself. The existing tools today, if you take a step back and look at the kind of tools that we have in the industry, they're disjointed and they're insufficient. The current tools today could be broken down into 3 groups of tooling. We have tools like SAST or software composition or container image scanning tools that look at the part application. These are either your code or your build images. If it's SAST, you don't have visibility into third party because you don't typically scan your third party. If it's an SCA tool, you do have visibility into third party as long as it's a known vulnerability documented as a CVE. That's about it. You're not at all looking at a running application. And especially for modern applications, it's extremely important, like I said, to look at all the aspects of running applications. Now let's look at the tools that we have that examine running applications today. We have DAST, Dynamic Application Security Testing Tools, and IAST, Interactive Application Security Testing Tools. IAST is 10 years old. DAST is 15 years old. These tools were designed before Kubernetes even existed, before DevOps even existed or was prevalent. Then we have container security tools. These are good tools, but they're designed for the operator. They're sidecars that look at your application traffic from the outside, and therefore they can find infrastructure-related issues. Is your Kubernetes configured right? Is your Docker configured right? But what you need to find from an AppSec perspective is look inside the application process, inside the container, as opposed to a sidecar looking from the outside. So you need something that looks at every thread, every process, every container of your application while it is running without you having to change any of the code and pass in all of this information to the engineering team if there's an anomaly that is detected. And that, in a sense, is what continuous observability is all about. So with continuous observability, you can start deep factor right when you start testing your applications, whether it's manual testing or automated testing as part of your CI, etc. And then you can choose to leave it on in pre-prod or even in production environments. You simply drop deep factor into your Kubernetes cluster. Or if you're not using your Kubernetes, you run deep factor with a simple command. dfcuttle is the CLI that we have. So you say dfcuttle run my app or dfcuttle run my container, or deep factor, insert the deep factor webhook admission controller into your Kubernetes cluster. It's very simple to drop in. But when you do that, you can do that in your manual tests by triggering it manually, or you can also bake it into your automated CI pipeline. Deep factor inserts a tiny little sensor into every container, every process, and it starts watching all of the behaviors that are happening there. What system calls did that process make? What library events did it exhibit? What process memory behaviors did it exhibit? What network activity did it show? All of that is then, all of this telemetry is then sent over to the deep factor portal. The deep factor portal assesses the insights and presents the anomalies according to 3 pillars of visibility. Know your supply chain, where it shows you these are all the touch points of your application, not just the dependencies that are sitting in your jar file. That's the old days of supply chain visibility. This is a comprehensive supply chain visibility, which is what ports did your application listen on? What files did it touch? What processes did it execute? So on and so forth. So it's a much more comprehensive supply chain. And the areas where it finds you the list of dependencies in your jar file, it tells you which of the functions and class paths were actually called by your application. So it's a complete runtime visibility into your supply chain. Second pillar is know your security. Here, deep factor will help you find risks all the way down at your system call level, all the way up to your web behavior. So most of the layers of your application behavior, security risks are identified and presented based on what your app was doing at runtime. And this includes the third parties that are baked into your application as well. And as we just discussed, a lot of the times, the amount of third-party code these days is much higher than your actual application code. In fact, the statistic is that about 75% of your application code for most web applications these days is third-party code. So finding risks that lie in these third-party code is important as well. The third pillar of visibility is know your compliance. How do your findings map to standards like NIST or ISO, 27001 or PCI, etc.? The compliance part is something that we're currently working on. It's going to be released early next year. However, the supply chain part and the security part is something that is available today, and the customers are taking advantage of that. So with this customer, what they did was they as they were in the process of containerizing their applications, they had several containers that were already created, and they have several more containers that will be created over the coming months. And Cadent actually took these containers and without making any changes to their code and without even trying to bother what language the application is written in, they simply dropped deep factor as a webhook admission controller into their kube cluster. And the deep factor portal was set up on an AWS backend. The customer was able to get insights around their application supply chain as well as security. And they plugged in to their Jenkins pipeline. When they plugged in, these were the types of insights that they were able to get all in one shot without having to utilize multiple different tools. They were able to get risks around application system call behavior, such as your application allocated memory improperly, or your application is susceptible to remote code execution attacks because there are areas where write and execute privileges, memory blocks were allocated with write and execute privileges at the same time. And things like that will help you catch these things early on and save you a lot of heartache later on when your app is running in production. Behavior violations, like the example of the third party that I gave you. Your developer brought in a third party. That third party is going to some unauthorized geography for network activity. And it's good to catch those types of things right the day when the third party is brought into your lab, as opposed to 6 months later when a pen tester comes in and finds these things out. Things like data risks, your application is using weak encryption, or you have keys left in your environment variables, so on and so forth. How does it map to privacy risks? The privacy part, like I said, is coming in the first half of next year. changes between releases and environments are important as well. The second category of insights that Defactor presented to this customer is software bill of materials. Like I said, it's not just the list of dependencies in your jar file, but it's much more than that. All the touch points of your applications, files, processes, ports, networks, usage of these functions and class paths that are sitting in your jar file were all presented to the customer. The other thing was software composition analysis visibility. So because Defactor gets to observe runtime behavior of the application, it can not only tell you that these are the vulnerabilities in the dependencies or in the packages that are part of your container image, but it can tell you which of them were actually used. That will help you reduce the volume that your software composition software composition analysis tools present to you. For example, if you choose to compare Defactor's results with the NIST database to get a list of vulnerabilities, you can do that. You can also integrate Defactor with a popular software composition analysis tools, like a tool like a Black Duck or a Sneak, if you want to use a third party. In this case, the customer chose to stick with the built-in NIST vulnerability database checks that Defactor does. Defactor also provides DAST insights because it's a great way to complement and augment the number of observability findings that your application presents to you. So we have Owasp Zap Scanners Zap Scanner that is baked in a headless, touchless manner into the Defactor portal itself. So all you have to do is invoke one command or click a button to start the Zap scan. You can do that for web scans as well as API scan. And while the scan is happening from the outside and your app is being scanned, you can actually observe. Defactor observes the behavior of the application from the inside because it is watching, the sensor is watching what's happening in the process. In this case, the customer is using the Owasp Zap Scan that is built into the product itself. Our recommendation typically is to have two separate pipelines, a short, quick pipeline and a longer pipeline. The short pipeline, you'll get all of the visibilities in 1, 2, and 3, but leave 4 for the longer pipeline because sometimes the DAST scans do take time. And you want to make sure that you want to make sure that the DAST scans aren't baked into the short pipeline, especially if your application has a big enough surface area of coverage. So in this case, the customer's Jenkins pipeline, they added Defactor to that, and the process is very seamless. When the developer merges code, the application starts running in their kube cluster as part of their automated tests. And these tests are performing standard regression, functional integration testing, and performance testing. And while this is happening, the sensor that Defactor drops into these containers is watching each of the containers and each of the processes inside the application. And as an option, like I said, if you are creating a long pipeline, you get to invoke the DAST scan as well. So you can scan the application and do more things with the application and exercise more code paths for observability to find more things. And all of these findings that Defactor finds, when you're finished with the regression testing and when you're finished with the scans, these findings are presented as a simple JSON and integrate into your Jenkins flow. If you can also come back and check out these insights in Defactor portal if you want additional details and alert evidence information, especially if a dev is wanting to fix the issue. Depending on the issues that you find and depending on the rule set that your AppSec team has created for you, you can get your builds or you can get your releases based on the, whether you found a list of P1s, so on and so forth. And then you go about releasing your application. If you want to create or assign tickets to your dev teams so that they can go ahead and fix some of the vulnerabilities or issues that have been found or patch them, you can use the built-in Jira integrations, or you can do that through the Jenkins flow itself. So that, in a nutshell, is what we accomplished for Cadent and helped them with their digital transformation journey. Thank you again so much for the opportunity to be presenting here. And I'm really excited that we won the DevOps India Summit Security Year. Thank you.